We use a one-sample confidence interval when we are trying to estimate the population mean. The confidence interval will be a range of possible means the actual population will lie in at a certain percent confidence. When we have to find the confidence interval of a problem, we will use a four-step process. We first state what parameter do we want to estimate and what confidence interval at. Next, we plan. We identify the inference method and check the conditions. Our inference method will be a one-sample t-interval for the population mean. We use a t-interval when our population mean is unknown. T is a critical value of the distribution. This is going to make a lot more sense with the picture here. So this is where at whatever confidence level, so here I have chosen at 95%, it will lie between the positive and negative t critical number. We will also need to know our degrees of freedom, which is n minus 1. For conditions, it's going to be random 10% and normal/large sample size. So the data should come from a well-designed random sample or an experiment. So that would be random assignment. 10%. When sampling without replacement, sample n must be less than or equal to 1/10 of the population size, or capital N. This condition does not apply to random assignment. And normal/large sample size. The population should have a normal distribution or the sample size is either greater than or equal to 30. If the population distribution is unknown or the sample size is less than 30, it does not mean we cannot find the confidence interval. We can graph the data using a histogram or scatter plot to look for normality. So here we found a bell-shaped curve when we make a histogram, and then for the scatter plot, you want basically just a approximately normal or straight line without any obvious outliers. Now we do. If the conditions are met, we perform calculations. We will be using a calculator for this section. It is the most efficient way to handle the AP exam and will be a way to save a lot more time. With the calculator, we will find the t-score and the confidence interval. Next, we conclude. We can use a sentence. We are C% confidence that the interval from A to B captures the true mean in context to correctly make our conclusion. Now we will try a problem together. The major pollutants of auto exhaust from gasoline engines are called NOx. Researchers have collected data on NOx levels in grams per mile for a random sample of 40 light-duty engines of the same type. The mean NOx reading was 1.267 and the standard deviation was 0.332. Construct and interpret a 95% interval of the mean amount of NOx emitted by the light-duty engines of this type. We will first state the problem. We want to estimate a 95% confidence interval of the true mean amount of NOx emitted by the light-duty engines of the same type. We will next plan. We will identify the inference method, which is constructing a one-sample t-interval for the mean population if the conditions are met.
We will now check our conditions, so we know that it's a random sampling of light-duty engines of this type, so that was given right here for a random sample of 40 light-duty engines. It's 10%, so we know that 40 light-duty engines should be much less than a tenth of the population of light-duty engines. And normal/large sample size, so our sample size given was 40, which is much greater than 30.
Now we do. We can now move on to the do. We will be using a calculator. When doing this, we need to make sure that we always state the critical t-value as well as the confidence interval. It is very common to forget to state the t-value. Here is how to find the t-value. So you're going to go to second vars, which is right here, or just distribution. From here, you can just go to number 4, which is inverse t, and then you need to put in your area, degrees of freedom. As stated before, degrees of freedom is n-1, sample n-1, and then the area is, so that's one area of the tails. So you can get that by, the area under the curve is 1. So you subtract your inside or your confidence, which is 95%, so 1 minus 0.95 is 0.05. You need to divide by 2 because you only want to put in the area of one tail. And then you input that in, and your computer output is negative 2.0227. That will be your t. And then for the actual interval, you can go to stats, and then you're going to start at edit. So you want to bring over, pressing this arrow to tests, go down to number 8, t interval, input all your data. Confidence interval is at a decimal, so not a percent decimal, so it's going to be 0.95. And then just plug that in, and then your output here is this interval. So now we can conclude. We're just going to use the same sentence as before. We are C% confident that the interval from A to B captures the two mean in context. So we just plug all of that in, our 95% and everything given here, and our calculated interval. So we are 95% confident that the interval from here to here, grams per mile, captures the true mean level of NOx emitted by this type of light-duty engine. And everything here from state to conclude is necessary to get the full score on your AP exam.